Hello everyone, and thank you for attending this Belzona Solve It session webinar on wind turbine maintenance from base to blade. Your host for today's session will be myself, Tom, and we also have Daniel, who will cover the technical aspects of this presentation. So what will be on the agenda for today's session? We will break this into two sections, a 20-minute presentation and a 10-minute Q&A session. So this is where we'll share or address any questions raised during the webinar. So if you can save them until this point, that would be perfect. Firstly, we are going to cover the range of Belzona application areas from base to blade before delving a little bit deeper into three particular sections. And now those are being transformers, shafts, and turbine blades. In each part, we will cover the problem, the Belzona solution, and some proven examples in the field. So now what I'll do is I'll pass you over to Dan, who will cover Belzona's base to blade solutions.
Good morning, good afternoon, good evening to all of you. So we'd just like to start with a broad overview of the variety of areas on a wind turbine where we can provide a solution. So the way we've done this is we split the turbine into three main areas. So starting at the bottom, we've got the tower and the base. There's a variety of solutions here. Primarily, it's the use of liquid membranes for general corrosion protection and weatherproofing, but we've also got concrete repairs for the foundations of onshore turbines, as well as corrosion protection and things like splash zones for the floating foundations of offshore turbines. So then we move up the turbine to the nacelle. This is where the magic happens and the electricity is generated. There's a variety of equipment here, most notably shafts, gearboxes, generators, and these are all liable to corrosion and mechanical damage. So we've got a variety of products that can help protect from future damage as well as repairing damage that's already there. There's also a few areas there that you might not have thought of, things like weatherproofing, inspection hatches. And then after the nacelle, we've got the blades. So these are the defining feature of the wind turbine. The most common application here is rebuilding the damaged blades and then applying a coating to protect them. But we also have a few solutions for the components where the blade attaches to the hub, such as the bearings. So what we're going to do now is take an application from each of these three areas and go into a little bit more detail on the problem and the solutions we've got. So the first one, we'll start at the bottom of the turbine, is a piece of equipment that's always going to be present where you're producing electricity and distributing it, and that's the transformer. So they're found in various locations around the wind farm. Sometimes they're even in the nacelle, they're not always at the bottom. But a common problem with these is transformer oil leaking from the cooling fins. So the metal on these fins is normally protected with a relatively simple paint system, and that's quite easily chipped or damaged. And when that happens, that allows the metal underneath to start to corrode. Left unattended, that will eventually go through wool and lead to cooling oil leaking from the transformer. So that can lead to overheating of the transformer, which results in inefficient operation of the transformer. And in the worst case scenario, it could mean the whole turbine needs to be shut down for maintenance. In terms of alternative repair methods, there's a few options. First, you could take the transformer out of service into a workshop for repair, maybe remove the fin and weld a new one on, or weld some fresh material onto the defective area. This can't lead to that. Or you could, the most extreme option there is to completely replace the transformer. You could take it out and put a brand new one in. And the majority of these methods are costly, not just in materials and labour, but also the amount of time that the turbine is going to be out of action and no longer generating electricity. So what are the Belzona products that we'll use? So the first two we've got here is Belzona 1161 and Belzona 1212. These are both paste grade materials that are designed for rebuilding warm material or bonding a double plate on there. And the key difference of these two is the cure time. So you can see 1212 is a rapid repair. You've got a working life of around 9 minutes, but that also means it's got a faster cure and a faster return to service. The other product we've got here is Belzona 5831. So this is a coating material, it's a fluid grade, and generally you'd use this after you've rebuilt the lost metal with one of the paste grades, then coat over the top with Belzona 5831. And that'll provide corrosion protection and hopefully stop the damage happening in the future. So a feature you might have noticed on all three of these materials is surface tolerance. So surface tolerance means this can be applied even onto wet or oily substrates. The material will displace the fluids, meaning that you can have a much quicker repair and get it back in service as fast as possible. So what I'm going to do now is hand you back over to Tom, and we'll have a look at a few examples of where we've already done these applications in the field.
Okay. Thank you, Dan. Just as a quick note, I saw one of the comments there mentioned that you couldn't see us, but you did have sound. What we do recommend is that you either refresh your screen or maybe close the window and just click on the link that was in the email that was sent to you just before this webinar. But as Dan mentioned, I'm going to cover some examples where Belzona has proven a success for repairing damaged transformers. So this first case history is from the UK in North Wales. The transformer was leaking oil, which was a major safety concern, as well as an environmental hazard to local farmland. The client's original option was to replace with a new transformer, as it couldn't be transported from site for any repairs. Overall, however, this meant that having the transformer out of action had a knock-on effect of £34,000 worth of losses every day. So it was quite a loss that they were making. As a result, they needed a quick solution, and in this they turned to Belzona 1212, a rapid repair surface tolerant solution. This meant minimal downtime for the client as well as maximum protection for the environment. So this is another example from a wind farm in the UK. The farmer who leased the land for this wind farm would still graze his sheep in the field. The sheep found that the transformer fins worked very well as a back scratcher. Now, whilst this wasn't great for the sheep, it was great for the sheep, it wasn't very good for the transformer's original coating. This wore away the protection, exposed the fins to the elements, and they began to corrode and leak oil. Now, the client had tried a makeshift alternative, but this still didn't solve the problem. So Belzona 1161, another one of the surface-tolerant solutions Dan mentioned, was chosen. For this, it was used to bond double plates onto the area, stopping the leak. So overall, a quick and simple repair that meant a fast return to service for the wind turbine. I'll now hand you back over to Dan, who's going to cover our second section on shafts.
Thank you, Tom. So now we're going to move up the turbine into the nacelle. And one of the most common components here is going to be the shafts. So any piece of rotating equipment needs to convert that rotational kinetic energy into electrical. So the most common cause of damage on shafts is wear, generally from imprecise alignment or a lack of lubrication. In some cases, such as the picture you can see there, a lack of grounding led to electrolysis and caused that pitting effect you can see in the image. So this wear will lead to mechanical damage on the extra components. An imbalanced shaft will damage everything that is connected to. And a less extreme case of that is simply it just won't work as efficiently as normal. Ultimately, what all this leads to is the turbine being out of action, downtime, and a loss in revenue. So your alternative options are generally to dismantle the nacelle, take the shaft out of action, take it to a workshop, maybe weld some new material on there, machine it back down to its original dimensions, or in some cases you could just completely replace the shaft with a brand new one. And one of the drawbacks of most of these methods is it means you have to take that shaft completely out of all the different components it's attached to and take it down to the workshop. As the Belzona alternative can be done in situ. So we've got a variety of materials for these. The first one is Belzona 1111. So this is the product you're most likely to have seen before if you're not as comfortable with all the products we have. This is a multi-purpose two-part epoxy designed for rebuilding corrosion wear, or on this case on the shaft. It can be used to bond plates on. It's a very, very versatile material. Then the other material we've got here is Belzona 1111 sister product, Belzona 1131. So this is very similar. Again, it's a paste grade material that can be applied in situ to rebuild the shaft. But this one has self-lubricating properties. So it's got a very low friction surface should that be required for the service. Then the final material we've got here is Belzona 1321. So to most of you might know that as an erosion resistant coating, but it can also be used to rebuild the shaft. So this is a fluid grade material that can be injected into the area, rebuilt using a former, and the ceramic field system allows for a higher wear strength as well as providing long-term corrosion protection there. So you might be asking yourself, how on earth do you rebuild a shaft using a fluid grade material? Well, we've got a video for you.
Okay, thanks, Dan. And as you mentioned, we're going to share a quick video with you. So I'm going to stop the screen sharing now, and I will share this video with you. Just as a quick heads up, if the upcoming video is a bit loud, you may want to adjust your speakers or your headphones accordingly.
In this video, we'll be demonstrating how to rebuild a damaged shaft using forming techniques. For this repair, we use Belzona 1111 in a metal former manufactured with an outside diameter slightly larger than the diameter of the shaft. First, we clean the damaged area of the shaft. We undercut the repair area and roughen the profile with a grinder. Next, we clean the prepared area to remove all surface contaminants. We applied Belzona 9411, a release agent, to the internal surface of the former. The repair area was then taped off and a layer of Belzona 9411 was applied to the surface outside of the repair area. Then, we removed the tape and mixed Belzona 1111 until a uniform material was achieved. The internal surface of the former was wetted out with Belzona 1111. Then, Belzona 1111 was firmly applied to the repair area on the shaft. A peak was created in the center to avoid air entrapment when positioning the former. Next, we positioned both parts of the former and secured them with bolts. The bolts were tightened to allow excess Belzona product to exude out. The exuded material was then removed and the former was left in place until the Belzona product cured. Once the product was cured, we removed the bolts and the former. We smoothed out the surface of the repair with an emery cloth and cleaned the repair area. Our rebuilding solutions for damaged shafts offer simple applications by reducing hot work and cutting downtime.
Okay, hopefully that video played okay for you. You may want to readjust your headphones or speakers accordingly again. I know we might be a little bit more quiet than the video was. So I'm going to share the screen again. And what we're going to do now is we're going to have a look at some applications in the field and how successful they were. So our first example concerns a wind farm in Texas, USA. Now, ineffective grounding of the turbine had led to electrolysis, and this had resulted in the pitting effect that you can see in your top left picture. This was having a significant knock-on effect, causing misalignment and destabilizing the turbine. Initially, the client's first thought was to take the turbine out of operation, dismantle the shaft, and take it to a workshop for further work. However, overall, this would have led to 2 to 3 weeks of downtime and significant cost implications as a result. So, the client used Belzona 1111 and repaired the shaft in situ. Due to the cold curing properties and easy application of this material, dismantling the nacelle was avoided, and approximately $250,000 worth of savings were noted with this simple repair option. In this instance, the customer had the ability to bring the equipment down for much needed maintenance. Rather than employing any hazardous hot work, Belzona was applied via injection, and what the client did afterwards is they used several different molds for all the shafts that they had in their turbine. So for each of the varying diameters, they were able to inject into the specific mold for each one and reform the shaft to its original dimensions. As we mentioned, the customer has a selection of different molds suitable for all shapes and sizes in the turbine and can complete the repair even quicker and simpler than ever before. So I'm now going to hand you over to Dan for our third section, which is wind turbine blades.
Thank you very much. So our final application we're going to talk to you about is my favourite part of the turbine, the blades. So although the turbines themselves don't spin overly quickly, it's normally in the region of sort of 10 to 20 RPM. The length of the blades means that the tips are travelling extremely quickly. In some cases, this is up near the 200 miles an hour mark, and this is only going to get faster and faster as the turbines are getting bigger and bigger. Now, the speed of these and the impact of water can cause significant leading edge erosion or damage on the blades, as you can see in those two pictures there. So this damage causes a loss in the aerodynamic efficiency of the blades and then consequently a loss in production. The effects of this can be seen after as little as 2 years sometimes, and the main effect is obviously this lowers the annual energy production. So sometimes this can be as much as 20% if the damage is really severe. You could even argue that it's 100% if the damage is bad enough to cause the blade to split. So there's various different materials that they use to repair and rebuild and protect these blades. Quite often they'll involve primers, multiple coats, sometimes UV lamps, tapes, various different methods. There's a lot of different products out there to rebuild them. But what we're going to do now is show you the two materials we'll use for protecting the blade. So some of the paste grade materials we've already seen you could use to rebuild, but these two materials here are just to protect from future leading edge erosion. So the two products in question are Belzona 1331 and Belzona 1341. So when you're looking for leading edge protection, you're looking for two things. First of all, performance. Does it stop the erosion? So both of these materials have been through extensive in-house testing, but also external erosion testing. So this also includes the ASTM G73 rain erosion test. In addition to this, we've got a lot of case histories and examples where we've used these materials in very erosive environments. So things such as cooling tower fan blades and high velocity pumps. But we also have examples as well where these have been used in the wind industry on blades. They both have an excellent adhesion onto the GFRP. So in most cases, when we do an adhesion test, the GFRP will break cohesively before the Belzona materials come off adhesively. The other important application or benefit you want from your leading edge protection is ease of application. This is very often going to be done in the field, often hanging off of a rope or on a platform like the gentleman you can see on the left. So you want it to be nice and easy and quick to apply. So both of these materials are very easy to mix, just simply in a bowl, and they can both be applied by hand with just a brush. The other point to mention about these is the application window. So these aren't moisture sensitive and will cure on their own without any need for external heating down to 5 degrees. So this allows a faster return to service, increases your application window, but it also increases the time over the year that you can get up there and do maintenance. So I'm going to pass you back over to Tom now for a quick video on rebuilding the blade.
Okay, so as Dan mentioned, I'm going to stop the screen sharing now, and I'm going to share our final video with you. Again, you might want to adjust your speakers or your headphones accordingly, as the sound might be quite loud.
In this video, we will be demonstrating how to repair and protect a damaged leading edge of a wind turbine blade with Belzona. For this repair, we used Belzona 1121 to rebuild the leading edge and Belzona 1341 to protect the blade from future damage. First, we sanded down the damaged area and removed the remaining coating and all the loose particles. Then, using an MBX bristle blaster, we cleaned the entire repair area, removed the dust with a brush, and degreased the area to remove all surface contaminants. We mixed Belzona 1121 until a uniform material was achieved. A layer of Belzona 1121 was firmly applied to the prepared surface of the blade using a short bristle brush. Next, an applicator was used to obtain a smooth finish. The excess product was carefully removed with a pre-formed mold. A smaller form was used to smooth out the blade's leading edge. Then, we mixed Belzona 1341 until a uniform color was achieved. A layer of the mixed Belzona 1341 was applied on top of the cured Belzona 1121. Using a thickness gauge, we measured the thickness of the Belzona 1341 coat to ensure it was applied evenly within the recommended parameters.
Okay, hopefully that video played okay for you as well. We're now going to just cover a few examples in the field, and then that will end the presentation and we'll go on to the Q&A session. So, the leading edge. Oh, sorry, I haven't shared the screen. That would be handy. There we go. Hopefully you can all see the screen properly now. So, the leading edge on these blades had started to show signs of deterioration, and the asset owner wanted a preventative solution to stop the effects of rain and environmental erosion. This damage was compromising the performance and energy output, and overall the life expectancy of the turbine. The customer had previously used a competitor leading edge coating, but this was found to be both difficult to apply and hadn't performed very well in service. So in this instance, the blades were brought down, the pitting was resurfaced, and Belzona 1341 was chosen to provide leading edge protection for the blade. Versus the previous option, Belzona 1341 was easily applied by brush, reducing the time taken to complete the application. Overall, Belzona offered them durability and performance that would eventually save them money in the long run. So this example actually won our Know How in Action competition in North America and Latin America last year. and I think the distributor who submitted this is in attendance today as well. This example actually resulted from the customer having seen Belzona's coatings work well within the coal power plant. The maintenance manager for the wind farm had used other coatings previously. These had either had performance issues though, or were logistically very difficult to apply. So Belzona 1341 was chosen once again. In this instance, they liked the ease of application and the smooth finish that it provided. As you can see as well, they chose blue actually for the final finish, which is a little bit different to the normal RAL grey typically chosen. This was ideal for the customer because it meant they could easily view the coating from the ground with binoculars, and if there was any damage to the coating, this would show up clearly against the blue, and they would know how to carry out, they would know if they needed to carry out any touch-ups. Which leads us on to another benefit of Belzona in that it wouldn't need to be reinstated along the entire length of the blade. If there was a need for part of the coating to be repaired, it could be done in a small patch repair. So I'm now going to hand you back over to Dan, and he'll provide a quick summary on the benefits of Belzona for the wind power industry.
Tom? So yeah, just a final slide just to summarise some of the benefits of using Belzona materials. So this applies to all of the materials that we've spoken about in this webinar. So the cold curing, solvent-free nature of them not only makes them safer to use, but it also helps the application. So there's no shrinkage or distortion of the material while it cures. They all have a wide curing application window, no external heat required, so you can have your turbine spinning as soon as possible. And they're all very easy to use and apply. In terms of performance, the materials we've shown today, they all have very good adhesion to the various substrates they're designed to go onto. There's way more products that we have in our range than we have time to talk about here for various different corrosion and erosive surfaces in various different temperatures. And the final point to make on these are long-term solutions, so they're not just quick fixes. For all the examples we've got here and many more, we've got case histories of proven performance where they've lasted for many, many years and still in service in most cases. So that is it from me for now. I'll just hand you back over to Tom.
Okay, so that brings us to the end of our presentation. We have touched on just 3 of the application areas Belzona can carry out in the wind power industry, but there are still many more which Dan briefly covered at the start. All of these systems have been tried and tested and have significant in-service experience from a variety of different industries and aggressive conditions. And just a final note, if you do want to receive any more information on Belzona's solutions for wind turbine maintenance, then we will be able to put you in touch with your local Belzona representative after this webinar. But all that leaves to say is thank you for watching, and now we enter the Q&A session of our webinar. So I know some of you have typed some comments and questions into the chat, so we'll cover those now. I'll now also enter in David Blackwell, our engineering director, to help answer some of these questions. Okay, so one of the first questions we had was from James. Can the blades be repaired in the air, or does it have to be on the ground?
No, they can be repaired in the air. If you use a specialist subcontractor who can do it by rope access, it's more than possible to do it. But in fact, a lot of the blades that we've done here in the UK have been through a rope access company who specialise in wind turbine repair.
Okay. James also asked, do you have technicians authorised to climb WTGs?
We don't have technicians in Belzona as such, or in Belzona Technical, but what we do is we subcontract the work to an authorised specialist in wind turbine repair who does the work on our behalf.
Okay. James, you also had another question. What are the curing temperatures and humidity requirements for the application? I think that was in reference to the leading edge protection.
Yeah, I think humidity is not really a problem. Obviously, we can't apply in the rain, so humidity is not really a problem. The only problem that humidity possibly would give is if the substrate temperature is below the dew point temperature for the atmospheric conditions that prevail when the job's done. But other than that, the humidity is not a problem. The temperature, our materials will generally cure from about 5 degrees upwards. Most materials that you find on the market need at least 18 degrees and above to fully cure. But Belzona materials generally will, obviously the cure time will take longer, but from 5 degrees upwards. C, that is, centigrade.
Yeah.
Okay. Hopefully that helped answer your question. Armando next had a question. Do you have rain erosion results for the leading edge protection?
Yes, we do have erosion testing done by two different companies. Just need to remind myself who they are.
One was Polytech in Denmark, and then there was another one done in the States. I can't remember who did that one.
Eon, Polytech, and NPL. So those are 3 independent laboratories that have done rain erosion testing on our products.
Okay, hopefully that helped answer your question. Nick, you also had one. This is about balancing issues. Would they be addressed by the specialists?
Yes, but generally speaking, if our materials are reasonably lightweight when compared with GFRP, and because of the way in which we apply the materials, which wasn't quite apparent in the video because of the editing sequence, because of that, we tend to apply roughly the same amount of material along the whole length of the blade. So generally speaking, balancing doesn't become a problem.
Okay, hopefully that one helped answer your question as well, Nick. Chris, did the Iowa application not use the 1121 under the coating? As far as I'm aware, it wasn't the 1121 under there, but it was 1341 that was chosen to go over the top. Obviously, some customers will have their own resurfacing material that they already use, but for the most part, Belzona 1121 will provide an excellent material to resurface the blades. As Dan mentioned, it has excellent adhesion to GFRP, and also one of the benefits of 1121 is it has a long working life. So you could actually mix this and apply it up in the air, either from the truck or from rope access.
Yeah.
So Jacob Knight asked, a wind farm I met with had a problem last year with a lightning strike which created a large amount of damage. They are interested in using the SuperApp 2 if it should happen again. What are your thoughts on that?
Yeah, I think that's entirely possible. SuperApp 2 application-wise is much the same as GFRP in that it's a resin-based system, composite, with carbon fiber reinforcement sheet. So laying up SuperApp 2 to repair lightning damage is very possible. Yes.
Okay, that damage was on the blade. So.
Yeah.
Yeah, I think it's very similar to the materials you'd use
Very
to
similar
rebuild a
to
blade.
the material that the blade's manufactured from.
Okay. Troy asked, I think he's referenced in the video, what were the blade edge formers made of?
I believe the second one was simply just a piece of rubber, not entirely. Oh, there you are. Alex has helped us out there.
Sorry, yeah.
So
Okay.
2000 series products for wetlands, so they form to the shape of the blade.
You would form them on an undamaged blade, of course, so you get the right contour.
Okay, so Armando asked, assuming the new blades don't need to be resurfaced, how long would it take to apply just the protection?
How long? Well, it depends on the worker that you've got. It depends on the conditions. Obviously, if you on the length of the blade, if you're doing it in the workshop, applying something like 1341, you could apply probably 15 to 20 square meters in a couple of hours without a problem.
Yeah.
Obviously, if you're doing it from rope access, it's going to take a little bit longer because of the situation. But it is very quick and easy to apply.
Okay. I think Frank also had another question. I think Keith raised it as well regarding testimonials for the wind farms. Like I said, we do have know-how in action, so case histories for all of these applications we've mentioned in a bit more detail. Obviously, it's something that we are also in contact with the customers themselves to get more information from, and hopefully just keep up to date with the progress with which the coatings are making.
I think a lot of the problems we have in terms of testimonials is we can get testimonials in writing from a customer. It's very difficult to get photographic evidence, particularly if the job's being done from rope access, because the last thing that the applicator wants to do if he's applying coatings to a blade via hanging on the end of a rope is stop and take photographs.
Yeah, so something we'd add on that as well is 1341 was actually put in a patent by Mitsubishi about 10-12 years ago, and all those blades have performed really well in service, and even some of them now are coming out of service because they've reached the end.
Yeah, that's an OEM specification for offshore blading from Mitsubishi. So all of their offshore blades are the leading edges are protected with 1341.
Can you apply 1341 on the new blades? Hopefully that last question answered that. So in the case of Mitsubishi, they were applying it directly on at the OEM stage. So yeah, there shouldn't be an issue with directly applying Belzona 1341 or 1331 at that initial mark.
Absolutely. Anything, it would be ideal. It would be much easier to apply than in the field.
Yeah. Jeff asked, in the video they said 1341 was applied to cured 1121. Did they wait for full cure, or can it be applied?
No. It's probably better. Well, it's definitely better to apply it as soon as the 1121 is what we call dimensionally stable. So if you use your thumbnail and it doesn't make a mark, then you can start overcoating immediately. You don't have to wait for the sort of full cure, and it has a very long, relatively long overcoating window anyway. So generally speaking, at 20 degrees C, for instance, you can be overcoating 1121 within an hour and a half to 2 hours.
James, you mentioned where you could get this webinar afterwards. Don't worry, you will be able to have a recording of the webinar, including the Q&A section, and that should be sent to you directly after this, so you can share it internally with other engineers that couldn't attend today. George had a question regarding transformers. Could we repair the pause because my customer does not want to take the transformer out of operation? By pause, do you mean pitting damage on the metal? If so, do you want to just quickly cover
Well,
that?
I would generally say yes, it can be repaired in situ. Normally what we would ask the customer to do is to drop the level of the oil in the transformer below the leaking area if possible. Sometimes that's not possible, but with our surface tolerant materials, we can actually affect a repair provided the static head pressure is not too great. I just need to point out there that the surface tolerant materials are surface tolerant to surface contaminations such as dust and debris, water and oil. The surface tolerant name does not imply that you can apply it to a surface without roughing the surface and doing any form of surface preparation. So provided we can do some surface preparation and we can degrease the area momentarily, then we can get material on and that material will adhere, and hopefully, again, provided the head pressure, the static pressure is not too high, then we can seal the leak.
Okay, I think that's covered a lot of the questions that have been asked. If you have any more, then please put them in the chat. Okay, I think Troy has just shared some some experience he's had with repairing transformers. So that's quite useful. Certainly, we can look at sharing some more information as well with regards to the patent that Mitsubishi issued a number of years ago. I believe it's available for public search on Google. But yes, we can try and provide that. Are there any other questions anybody else has? Would they like to submit them in the chat or through the audience question section? If not, there is a opportunity to submit any comments or questions you have at the end of this webinar with a very short survey, just to see whether you found the content useful. So I think what we'll probably do is we'll leave it there, but hopefully you found this informative, and we look forward to seeing you at maybe another webinar we're hosting soon. Okay, thank you very much.
Bye. Bye.